Question 1. Ask you from this formula, ask you number of proton, neutron, and electron. Carson 2040. Carson 2040. Let's see. How many proton? Clearly, this is a smaller number, always proton number. How many neutron? Neutrons number always a difference between these two because this is proton number. This mass number is proton plus neutron. The mass minus proton is a neutron. Right? 40 minus 20, still 20. Right? Then how many electrons? You need to take a look. Is there any charge? Here, no charge. Then proton number equals to electron number, still 20. Next symbol is Br minus 3580. Then proton number always this smaller number, right? (35). Neutron number always mass minus proton. 80 minus 35, which is 45. Electrons number. Now you need to be careful. This is minus 1. This is on R. Minus 1 means gain 1 extra electron. If no charge, electron is this proton number, 35. Now gain 1 extra, 36. Right? This means 35 gain 1 extra, 36. Okay, you get it? During the test, I may give you this positive charge cut on. Then you need to be careful. Positive 1, you need a minus 1. If positive 2, you need a minus 2. If negative 2, you need a plus 2. Get it? Okay. And this is 8. Proton, neutron, electron. They give you molecular formula, ask you empirical formula. Molecular formula C5H10O5. How can we get an empirical formula? We need to simplify it, right? The molecular formula tells you exact number of atoms from each element. Empirical formula, the symbol is the whole number ratio of atoms from each element. This means we need to simplify this 5, 10, 5. How can we simplify? Very clear. Here, everybody divided by 5. Right? So 5 divided by 5 is 1. 1 omits. 10 divided by 5 is 2. Right? Then 5 divided by 5 is 1. 1 we omit. Is this easy? This is very easy. Most of you get it correct. We have several. Answer is CH5 too. I don't know how can you get a 5. 10 divided by 5 is 2. If you double check before you turn in, you can easily find this mistake. N2O4. This is easier, only 2 elements, right? 2, 4. Then divided by 2. So NO2. Okay. Next question 2. About the nucleus of an atom. Account for A, most of the size and the mass. That's clearly not right. Right? So do you remember in the model of atom looks like this? If this is atom, in the center of a very small space, we call nucleus. But mass is concentrated because in nucleus we have proton and a neutron. Electron travel around it. So electron's mass is much lighter compared with proton and neutron, right? So this model tells you very small space in size, but most of the mass concentrated in nucleus. So your answer must be D. Most of the atoms mass, but very little of its size. D is your answer. You get it? Yeah, we can. I don't know if you remember. Oh, no, this is chapter 3. Let's open chapter 2. Sometime very chapter 2. Okay. Just think about this model. Right. If this is atom, most space empty. In the small space in the center, this nucleus, you have proton and neutron. Proton's mass is much heavier than neutron, much heavier than electron. Neutron's mass is similar as proton. Just think about this as a model and understand. The choice is D. Most of the atom mass, but very little of its size. Then question 3. The element in the horizontal row of a periodic table are known as what? Horizontal row, like this. Period 1, period 2, period 3. So this name is period. The element in the same vertical column we call group. Okay. Careful, in the test, I may test you group instead of period. And so here your choice is B. The element in the horizontal row of the periodic table are known as a period. So your choice is B, period. 4. Which of these elements is a metal? A, nitrogen. No. Okay. By the way, what elements are metals in the periodic table? Underneath this diagonal line, all elements are metals, right? Above this diagonal line, no metal. Don't forget this. This is also above diagonal line, no metal. On this diagonal line, metalloid. Okay. So metals are underneath this diagonal line. So nitrogen definitely be above the diagonal line. Nitrogen is no metal. Sulfur, same, no metal. Calcium, chlorine above that, right? No metal. So only calcium is a metal. So your answer is C. Only calcium is a metal. Number 5. When forming charged particle, give explanation in the parentheses. Ions. Charged particle we call ions. Which of the following can occur when an atom gain electron becomes cation? When an atom gain an electron becomes anion, negative charge. Right? When lose electron becomes cation, positive charge. Anyway, electron can be gained or lost. We never say proton or neutron can gained or lost. Right? So your answer is C. Electron are lost or gained. When form charged particle, which is ion, so electron can be gained or lost. Not proton, not neutron. Neutron, proton in the center cannot be lost or gained. Okay. Question 6, naming of these compounds. Aluminum is a metal, right? Oxygen, non-metal. So this is ionic compound. Ionic compound, you don't need to use prefix, as di or this tri, you don't need to use it. But if this matter is a transition matter, what means transition matter? Matter in this range, right? Except the last one. Or this plus this, because this is a lanthanum series in this box. This is actinium series in this box. This we need to use a Roman number to indicate it's a charge. But aluminum is not a transition matter, right? Aluminum is here. So you don't need to use prefix. You don't need to use Roman number. So aluminum, still aluminum. Then oxygen, you need to change it to oxide. No matter change N to IDE, right? KOH, K, the name is potassium. OH, the name is hydroxide. Potassium hydroxide is a base. So base is metal name, hydroxide. Then next one, N2O5. N2O5. And nitrogen is no matter. O, oxygen also no matter. So this is a molecular compound. Molecular compound, we do need to use prefix to indicate each atoms. How many atoms for each element, right? 2 nitrogen, di-nitrogen, right? Di is for 2, mono is 1. Di-nitrogen. The 5 oxygen, prefix is pent. Mono is 1, di is for 2, tri is for 3, H is 4, pent is 5. Pent used to be P-E-N-T-A. Since oxygen first letter is O, so you omit the A. So pent oxide, you do need this prefix. This is for molecular compound. Okay. Question 7 is the opposite. This time give you name of your chemical formula. Chloric acid. Chloric comes from chlorine, right? So this everybody know. Acid always have hydrogen there. Is this formula correct? No, no. Chloric acid, no hydro. This means there are oxygen in the formula. If this is acid, then you should have hydro. Right? Start with hydro. If no hydro there, this means you have oxygen in the formula. Then how many oxygen? 1 or 2 or 3 or 4. Wow, 4 different oxygen numbers could be, right? Chloric means 3. If HClO4, then you need to give another prefix per chloric. If this is O2, then this name is not chloric, it's chlorous acid. If only 1 oxygen, then we need to give another prefix, hypochlorous acid. Okay? Copper 1 oxide. Copper 1 oxide. Copper. What is the symbol? Cu, right? Oxygen. Right, oxide comes from oxygen. So your job is to figure out how many copper needed, how many oxygen needed. Be careful, this Roman number 1. This means copper's charge is 1, not 1 copper. Copper's charge is 1. What is the charge for oxygen? Oxygen is from group 6A, right? Again, group 7A, most case, -1 in the compound. 6A, -2, right? So oxygen in group 6A is -2 charge. And copper is a +1. Copper as a metal always positive, right? Metal always positive in the compound. This 1 means +1. Then you need how many copper? Of course, 2, right? Your formula will be Cu2O. If you write CuO, the name is not copper 1 oxide, but copper 2 oxide. Again, this is for the other class. Okay, copper 2 oxide. Another is sodium hydroxide. Sodium, the symbol is Na. Hydroxide, hydro is hydrogen, oxide is oxygen. But the formula is OH, not equals to HO. You cannot write this. No. You need to follow the rule. Other chemists agree. Even if in the future you become a very famous chemist, but you cannot change the rule by yourself. This is through some committee, and everybody, at least most scientists agree. Not HO, is OH. Hydroxide is OH. Okay. Yeah, for this one, sodium hydroxide, we have many mistakes. And one student write this. The sodium S, no, S is not sodium. S is sulfur. This is wrong. Okay. We have many different mistakes there. The correct answer is NaOH. Sodium is Na. Hydroxide is OH. Okay. Then number 8. Which of the following compound is an acid? What means acid? Any substance dissolved in water can give off hydrogen ion, right? So you must have hydrogen in the formula. Then among this choice, only this one is acid. How hydrogen can be give off in water. Then how about this? It's clearly this is base, right? OH is base. Then how about NaNO3? This is not acid, not a base. This is what we call salt. Okay. You may confuse the salt is this, right? Everyone knows this table salt. Table salt is just a special salt. We can eat it. The name salt is a very broad definition. Salt is any ionic compound. So cation cannot be hydrogen. If it's hydrogen ion, then this is acid, right? For the ion cannot be OH minus, because this is base. Also, ion cannot be oxide or other ionic compound. Salt. Say this, NaNO3. Na is cation ion, not hydrogen. NO3, not OH, not O minus, or not O2 minus, or O minus. Right? Salt. So for question 8, acid, of course, only this choice. Question 9 asks you which of the following compound is a base. First choice, right? So this is a question 8 is B, is HCl3. Question 9 is A, is this, right? MgOH minus OH2 OH. There is clearly the base. Or other three same as question 8. HCl3 is acid. NaOH3 is salt. KBr also salt. Okay. Question 10. Which of these is ionic compound? So ionic compound mostly is matter bind with non-matter. Then which one? SO2, S is non-matter, O also non-matter. No, not ionic compound. NH3, nitrogen, hydrogen, both non-matter. Look at your table. Calcium, oxygen. So calcium here, this is matter, right? Underneath this diagonal line, this calcium is matter. Oxygen above this diagonal line, no matter. Matter, no matter. Ionic compound. So question 10, your choice is C. Calcium oxide is non-ionic compound, or others are molecular compound. So matter bind with non-matter bind with non-matter, or non-matter bind with metalloid, or molecular compound. Question 11 asks you which of the following chemical reactions is possible according to Dalton's atomic zero. Dalton's atomic zero. This is the first slide, chapter 2. Talk about any chemical reaction. Elements cannot be created or destroyed. Right? According to this principle, only A is possible. So A, say nitrogen react with hydrogen, produce ammonium. Before reacting 2 nitrogen there, after reacting still 2 nitrogen. Before reacting 6 hydrogen atom, after reacting still 6 hydrogen atom. How about B? CH4 becomes, no, CCl4. We have students choose this. You need to be careful. Before reacting, this Cl, after reacting becomes H. This is different element. And choice C is hydrogen react with oxygen, produce water plus Au. Where this Au comes from? Au is gold. If we can make, if this reaction is possible, that means we can make Au from hydrogen oxygen. Then Au will be very cheap. You know, in these days, gold as a fine metal becomes more and more expensive. If we check the market, every day change goes up. If we can make gold from hydrogen and oxygen, this cannot happen. It will be very cheap, right? Oxygen everywhere. No, atomic zero tell you elements cannot be crashed or destroyed. This tell you gold elements, gold can be crashed from other elements. It's not possible. How about the last one? Carbon react with oxygen, produce water. Where is carbon of the reaction? Where does hydrogen come from? Right. So all not possible except A. Only A is possible. Question 12. Which of the following is a compound? Is this a compound? No, because only one element, right? To qualify as a compound, it must have at least two different elements combined. Now, how about this? Also one element, right? Sulfur. FeO. It's clearly two different elements, right? So your choice is C. And the rest you don't need to care. Or is one choice. F, very clear. Just one element, right? Do you have any other question? If no, we'll come back to chapter 3.